Hi, in this section we're gonna cover a Taewin theorem. Basically, what you're gonna cover theorem explain. Then we're gonna give examples. Then we're gonna give exercise questions. Okay, Taewin theorem is basically like this. If you have a two-terminal circuit like this here, okay, two-terminal circuits, we can replace this one as one voltage source and serial one resistor. We call this voltage source as open circuit voltage at the terminal A and B right there. And we call RTH is the input equivalent resistance at the terminal A and B. The reason we do this one here, if we loading anything right there after that one, we can find for different uh, values, different uh, elements right there easily. How are we gonna do this one here? How are we gonna find VTH and RTH? Okay, to find VTH, we're gonna take the load elements out from between A and B. There is nothing right there anymore. Okay, we're gonna take open circuit right there. So VTH will be open circuit. We're gonna find the voltage right in this point here. That will be our VTH. Okay, one more time. Take out the load elements. Find the voltage between A and B. Okay, that will be our VTH. RTH. For RTH, we have two cases. Case one, this is important. If the network has no dependent sources, we will turn off all independent sources, which means voltage source will be short, current source will be open circuit right there. Then we're gonna look at the resistance value from between A and B, find the resistance value. That resistance value will be RTH, which is our input value. Okay, case 2 here, if, because VTH doesn't change, RTH. Case 2, if there is a dependent sources. Again, we're gonna turn off all independent sources except dependent sources. We're gonna leave them. Okay, dependent sources are not to turn off. Okay, then we're gonna apply voltage source between A and B, known value, which is V0 right there. Usually we can apply 1 volts voltage source right there. Then we can find that current I0 going to circuit right there. Then RTH will be equal V0 divided by I0, or 1 volts divided by I0. You can find it here. Or if you want, you can apply current source between A and B. Then you can find the voltage right there. So we can find RTH V0 over I0. Easily for me, I usually apply voltage sources, but some cases maybe needs to apply to solve the question easily. We can apply current sources. Okay, we're gonna give example for both cases. Okay, first example, there is no dependent sources, so we have independent sources. So this is the RL here. Question is, using Taewin equivalent circuit, the following circuit, then find the current through the RL right there. This is the one we're gonna find it. Okay, so basically what we're gonna do, we need to use this one as maybe A is right there, B is, we're gonna, this box here, we're gonna represent that one is one voltage source VTH and one serial resistor. Let's do the resistor first. Easy here, because if I take the voltage source out, that will be short circuit. If I take the current source out, that will be open circuit right there. When you look at from between A and B here, RTH, you can see 40 parallel to 120 here, then serial to 100. So basically 40 parallel 120 plus 100. So 40 parallel to 120 give you 30 ohms plus 100, so 130 ohms. This will be our RTH. Let's look at a VTH. So again, we're gonna take the load right there. We're gonna look at from here. Then we're gonna find the voltage. Let me show you that circuit in the next slide here. The circuit from right there, the voltage source, current source, whatever you have, independent, dependent, it's gonna be there. So the point, we need to find the voltage over the A and B right there. Okay. If you look at this circuit, VTH actually is equal to voltage in this point right there. The reason is this one, because there is no current goes right there. That means whatever voltage you have here, you have same voltage right there too also. Same thing, we can say, oh, voltage, same voltage right there, here too also. So if I can find the voltage over the 120 volts, 120 ohms resistor, then I can find VTH. That's my VTH, right? Two ways you can solve this one here. One is mesh analysis. The other one, you can apply KCL. It's up to you, whichever you prefer right there. So first, actually here, if you look at, let's use the mesh. So if I set mesh right this point here, negative 20 volts plus 40 and 120 I1, negative I2 goes opposite, negative 120 I2. If you look at the mesh, second one mesh right there, we can see I2 is actually equal negative 0.1 ampere because they're opposite. So I2 will be negative 0.1 ampere. If you apply this one right here, then we can find I1 easily. When you find I1 here, if I want to find the voltage over the 120 ohms resistor, basically V120 ohms will be equal 120 times I1 minus I2 here. The reason is I1 is going this direction, I2 goes opposite direction right there. That's the one we have right there. It's give you 18 volts right there. So our VTH is 18 volts. Our RTH is equal 130 ohms. If you say, no, I'm going to apply there KCL. So you can apply KCL right there, and this is the one we know is going there. This will be here 20 minus VTH divided by 40, and this will going down here. If you say here, you can say, or the other way you can use right there, negative VTH 120 plus going in here 0.1. So only unknowns VTH, you can find VTH here, which comes to 18 volts again. So we know VTH, we know ITH. So we can put the RL load resistor back between A and B. If I want to find the IL is easy, VTH divided by RTH plus RL here. So it depends on which RL value you have it, you can find the values of IL. So it's 60 ohms, we put there 60, that's why coming here I4 value or RL, I should maybe call RL right there, better for me. Okay, 120, you put there 120, current value. RL is equal to 360, you put there, you can see here. Then we have one exercise question. I want you guys to focus on this one, do it, and we can discuss this one in the class. I will not gonna explain too much, or I can explain a little bit here. What you're gonna do, this is the one you're gonna separate here. So insert the row right there. Basically, you need to represent this one as one voltage source and one serial resistor. Okay, again, there is no dependent sources. We can find the RTH easy, take the sources off. This will be short, this will be open, so you can see here two serial and parallel right there, you can see it easily. Then next one, you're gonna find the voltage between here, that voltage give you VTH. Okay, next question here, if we have dependent sources, this is a little bit different. Okay, so the different parts RTH, VTH same again. So we're trying to find the volt, this point here. So we're gonna represent this everything right there, one voltage source VTH and serial resistor RTH. So to find the RTH in this circuit here, um, because of the voltage source right there, we're gonna take this voltage source out. That's why it's open right there. We're gonna apply right there one voltage source. Simple way, apply there 1 volts. So you have only this part circuit here. I would like to try and find I0 here. My I0, if I have a 2-3 mesh equation, right? I select mesh because of this voltage source right there between two non-reference. So we know that I0 will be equal negative I3 right there, mesh, right? So we can write them if we want to write them together here. I1 is the first one right here. So what's gonna be negative? What is it? Let me see. I can read it. I think I covered that one. Oh, negative 2Vx and plus 20 I1 minus 20 I2 equals 0, first equation. If I want to write this one here, we have here, first one is, let's my I1. I1 is negative 20. Then plus I2 will be equal 40 plus 20 plus 60. So 40 plus 20 plus 60 I2. Then minus here, oops, minus 60 I3 equals 0. That's second equation. Third equation we're gonna write, you can write from here. That one is, there is no I1 there. I2, there is negative 60 I2, plus 60 plus 20, 60 plus 20 I3, then plus, what is it, 1 volts, 1 equals 0. Okay, so we have three equation, three unknowns. We can put in the matrix form. We can find out the I3 there, put in the matrix form right there. We can find I3, then we can find I0. When you find I0, again, I0 is we find is here 0.166 ampere right there. We know V0, which is 1 volts, so we can find RTH equal V0 divided by I0. That's why we have 60 ohm. Okay, find VTH exactly the same like independent sources. It's still open right there. We need to find the voltage right there. Basically, that voltage is same voltage right there because this is open right there. There is no current, so same voltage right there. So if you want to apply node, fine, but we have this one is non-reference, so that's why we apply their mesh. So we have one mesh equation right there, one mesh equation right there, one mesh equation right there. We can write them. Then apply them. Actually, when we can find the do we need to write them? I can write it. Let me see how much time. 14 minutes videos. First one is actually I1 is equal 0.5 directly. I1 is equal 0.5 ampere. Done. Second one is right there. If I want to have I1, it's gonna be equal negative 40 I1 plus 40 plus 20 plus 60, so it's 120 I2 and negative 20 I1 I3 equals 0. If you write the third one, is right there top. This is number 1, this is number 2, number 3 is from top. There is no I1 there. there is negative 2Vx plus 20I3 negative 20I2 equals 0. What is Vx? I look at the Vx right there. Vx is basically equal I1 minus I2 times 40, or I1 is equal 0.5 minus I2 times 40. So apply this one, this two equation two unknowns. You can find them easily. I2. So I0 equal negative I3 you can find from right there. So we can find Vth easily from there. Okay, so we can represent this one in simple way with one source Vth and one series resistor. I have a similar question here, and with the dependent source. I want you guys work on this one here. We can discuss this one in the class.